covers dietary balances, and in particular, the regulation of feeding, obesity, and starvation. The second webinar will include vitamins and minerals, which is something that you've covered in biochemistry, so it's more of a review. Now, dietary balances, we're going to start with just talking about just energy intake and output. When you look at the intake of energy, which is by the food that we take in, we utilize that food, or we metabolize it to get energy to do various processes in our body. Now, the energy that we require for various processes in our body will depend on a lot of different things. I mean, you have your basal metabolic rate, just to kind of maintain the status quo, and then you're going to have some that may be involved in, if you're physically active, which is obviously variable depending on the person. We have some that's going to be involved in temperature regulation and other different functions. So if you want to kind of stay pretty much your same body weight, the amount of food that you take in, which equates to the amount of energy that you would take in, needs to be equal to the total energy output. And if the intake is equal to the output, you're considered to be in energy balance. So you'll be this guy in the middle. You're just going to stay the same weight. Well, if you consume more energy than your body expends, you're going to gain weight. So you're going to get a little chubbier like this person here. Not necessarily chubbier, because you can be in positive energy balance, and not because you're gaining fat, it's because you're building muscle. So being in positive energy balance isn't always a bad thing. Now, if your intake of energy is less than the output, then you're considered to be in negative energy balance, and you're going to lose weight. So let's kind of think of some examples of people that may be in positive energy balance, where it's good, or may be that it's bad. Well, a lot of people that are not as active and they overeat the wrong things, they start gaining a lot of weight, and that weight tends to be a lot of fat. Not necessarily a good thing. But people who are in positive energy balance, and it's actually a good thing, is pregnant women. They're going to be in positive energy balance. Growing children. Anybody who wants to build muscle. So if you have certain athletes, or just anywhere off the street who wants to gain a little bit more muscle, they'll be in positive energy balance. Well, negative energy balance, people would, if they want to lose that excess weight they have, they need to be in negative energy balance to the point then they're at the weight they want to be, and then they need to make sure the intake was equal to the output, and so they can stay the same weight. Now, on both extremes could be unhealthy, because if you continue in this point, that you start taking away from vital organs. Like if you have to start using proteins for energy, this may be a bad thing. And here, obviously, excess weight's not a good thing on your heart either. Now, when you look at the fuel that we take in, it has the energy in it. We intake carbs, fats, proteins. Those are our major macromolecules. And most people remember that fats have a little bit more than twice the amount of calories per gram. So they serve as a more dense energy source than carbs, and consuming fats for energy is advantageous for certain individuals because they kind of, in other words, get more bang for their buck. But people also have to realize that when you intake a lot of fats, fats are more easily converted to the fats that we store as triglycerides, or the triacylglycerols. But both carbs and excess proteins, if you take them in, can also be stored as fat. Now, the bottom of the screen talks about a typical American diet. Now, I really don't even believe in them telling typical American diet. There's so many people out there that have different intakes of carbs, fat, and proteins. But overall, though, the American diet tends to be very high in fat, which is not a healthy thing. We do need to eat fat, but most Americans consume a lot more fat than they should. And we look at, what I want to talk about just briefly is protein intake. Why is it very important to have an adequate protein intake? Well, we have a daily requirement for protein, and they say a range between 30 and 50 grams per day. Now, 50 grams is kind of like the average value they give out give to people, but it will range depending on the individual. Certain individuals who work out a lot, bodybuilders, things like that, they're going to take in more protein than other people, but this is about a normal actual or average value is about 50 grams per day. Now, if you consume a lot of incomplete proteins, if you're not a meat eater and you eat a lot of incomplete proteins, then your requirement's going to go up because you need a lot more different proteins to end up being a complete protein. The idea, though, is when you eat, you should have carbs and fats because they're considered to be called protein sparers. The protein that we intake is not for energy. The protein that we take in are providing us with building blocks to make the proteins that we have in our bodies. They're structural proteins, they're enzymes. Proteins have a more functional role in our bodies in regards to structure and a lot of things like protein pumps, things like that. Carbs and fats are utilized a lot, primarily, you think about it, for energy. And if you consume carbs and fats, we won't go and use the protein that we intake for energy. And the idea is if we don't consume enough carbs or fats, and you don't, again, are not consuming proteins, you're going to break down your own protein stores for energy, and you're going to end up with muscle wasting. Now, you can determine how much protein that you're metabolizing by measuring the amount of nitrogen that it's excreted, since nitrogen is a component of proteins. And they can estimate it by looking at the amount of nitrogen in your urine. It's an easy sample to take. Is here, give them some urine. And you can estimate it by taking the amount of nitrogen in the urine. You add 10% to it, because the idea is 90% of the nitrogen is excreted in your urine, 10% in your feces, so they kind of add that back, and then they multiply it by 6.5. This value comes from the fact that the average protein, it contains about 16% nitrogen, and that ends up being, the conversion factor ends up being 6.25. Now, an example that I see at the bottom, someone's figuring out the number of grams of protein that they metabolize per day. You see that this person's about 55 grams. Well, what's so important about that? Well, if I'm metabolizing 55 grams of protein per day, I better be ingesting at least 55 grams of protein per day to make up for that metabolism of protein. Otherwise, again, you'll end up with muscle wasting. Now, do not worry about knowing this mathematical equation about estimating the number of nitrogen. I won't ask you that at all. But what I may ask you about is the idea of nitrogen balance. So if I'm a person that's metabolizing 55 grams of protein per day, if I want to be in nitrogen balance, where my intake is equal to my output, I must ingest 55 grams of protein a day. Well, some people are considered to be in positive nitrogen balance, where their input of nitrogen, their ingestion of these proteins with the nitrogen, is greater than the output, their excretion of nitrogen. So examples of people that will be in positive nitrogen balance: children, because they're growing; pregnant women. You also may people that are recovering from illness or injury, because their bodies are going to require extra protein in order to build the tissue. So people who are recovering from an illness or injury need to ingest more proteins to compensate for the requirement for extra protein. The people that may be in negative nitrogen balance. Now, these are individuals that their nitrogen input is less than the nitrogen output. So the body is pulling out protein, is metabolizing the protein in their bodies to do whatever they need to do. Well, people that are negative nitrogen balance are people who are not taking enough in their diet, just dietary imbalances. A lot of people, specifically women, are notorious for this. They want to try to lose weight, and they start eliminating meat because they're like, meat's got more fat in it, so they start eliminating a lot of meat, and so they don't get enough nitrogen or protein and nitrogen. If you've got a lot of stress, an illness or infection and you're not consuming the extra nitrogen, or I keep saying nitrogen, extra protein, then you will start metabolizing your own protein sources. Now, another thing that looking at for energy usage is looking at something called a respiratory quotient or respiratory exchange ratio. Now, I had mentioned this a little bit in Physiology 1, and I'll kind of remind you what each means. Now, a respiratory quotient, this is looking at a ratio of the carbon dioxide that you produce and your oxygen consumption, and now this is at the level of the tissues. So at the level of the tissues are using oxygen and producing carbon dioxide as a byproduct. So that ratio is considered the respiratory quotient. The respiratory exchange ratio is the amount of carbon dioxide that you expire in your air at the level of the lungs to the oxygen absorption. So this is at the level of the lungs. Now, if you measure this for over an hour, generally the respiratory quotient will be equal to the respiratory exchange ratio. So we will be able to utilize that respiratory exchange ratio as a means to estimate or look at what your body is using primarily for fuel, and it's used in a measurement for determining basal metabolic rate. Now, what I want to ask and see if you can kind of use a little bit more critical thinking is if I just finish a meal. So you just ate we're just going to say a well-balanced meal. You should be able to kind of figure out what do you think the respiratory quotient of that individual will be. Now, before we could do that, I have to explain to you that the respiratory quotient for certain fuel sources will be different. So if I'm eating completely carbohydrates, my respiratory quotient will be 1. If I'm consuming just fat, the respiratory quotient is 0.7. And if I just consume proteins, it's 0.8. Now, how you get the different numbers comes from the fact that you produce a lot more carbon dioxide for the metabolism of carbohydrates than you do with either fat or protein. And you can go back to your biochemistry and kind of look at those metabolic pathways, and you can see that you do produce more carbon dioxide from metabolizing carbohydrates. And it's pretty much a 1-to-1 ratio. For every oxygen you consume, you produce about 1 carbon dioxide. So if I just finished a meal, what do you think the respiratory quotient will be? Well, if I have a well-balanced mixed meal, it's like, well, it's got to be a mix of everything. They say it's about 0.8, but generally, just following a meal, you predominantly use carbohydrates for energy. That's what you preferentially will use for energy. So immediately following a meal, I probably would estimate the respiratory quotient to be closer to 1. Well, what's more important is like looking at what happens about 8 to 10 hours after you've eaten. Generally, whatever you've eaten, you've used that energy within about 2 hours. So now you're 8-10 hours after a meal. What are you predominantly going to be using for energy? You should remember this from biochemistry, is as you predominantly use for energy starting 8-10 hours after a meal is fat. And so if I'm using primarily fat, my respiratory quotient will be about 0.7. Now, if I'm a diabetic, I have diabetes mellitus. So and this is type 1. So that means I'm not producing insulin. And if I'm untreated and I'm a diabetic, my body cannot use glucose or carbs efficiently enough for energy because of lack of insulin. So they predominantly use fat for energy. So people with untreated diabetes mellitus would have a respiratory quotient of about 0.7. Now we're going to change gears a little bit and talk about factors that help us regulate the amount of food that we take in, or feeding behavior and energy storage. So there's a list of definitions, and I've actually defined them for here so you can fill them out in your manual. So I'm just going to talk about them as you fill out the definitions, because I will ask you the definitions of at least 1 or 2 of these for an exam. Now, all these things ultimately are linked to food intake or feeding behavior. So if I have a good appetite, most people realize if I have a good appetite, I want to eat. I have a desire for food. If I don't have an appetite, I don't really care about eating. Okay, I have no desire for food. Then you have a term called satiety. If you have this, it's a feeling of being satisfied. If whatever, say if we use this in regards to food, feeding behavior, if you have this feeling of satiety, you're satisfied. Whatever you ate, you're good to go. If you're insatiable, that means you eat and you're never satisfied. And there are clinical conditions where people never get that feeling of being satisfied. And you'll see those people are extremely, extremely obese, more majorly obese, if they don't have that feeling of being satisfied. Then you have hyperphagia. This is a condition in which people are voracious eaters. So phagia has to do with eating. Hyper, kind of excessive. So these people are voracious eaters. They just eat and eat and eat and eat, and they just love to eat. So that's hyperphagia, and they would tend to be overeating. Aphasia is just the opposite. If you have a condition of aphasia, you do not want to eat. You refuse to feed or eat at all. So A meaning kind of lack of or none. Now, think about, there are some people who have aphasia. It's a refusal to feed because either they just don't want to eat at all, because they are kind of, it's more of a, maybe for, what's the word I want? They're protesting something. So I'm not going to eat until this happens. And you've had people who've went on hunger strikes for this. But then you have people who have aphasia, and it's a clinical condition where they just don't want to eat and they refuse to eat, and that's obviously not a good thing. If you have a condition called inanition, this would be considered to be the opposite of obesity. So it is considered the opposite of obesity. This condition is associated with people who are losing weight. They're going to have muscle weakness because in the process of losing weight, they're probably losing muscle proteins, so it leads to muscle weakness, and they have decreased metabolism. Your body adapts as you lose weight to lower your metabolism also a lot, because it's like, I don't know when I'm going to get my next meal. I want to be as efficient as I possibly can. That's why it's you realize that as you lose weight, it gets harder and harder to lose weight, and even more if you lose muscle, because muscle is more metabolically active than fat. So people who have this condition of inanition, you're going to see them losing weight, they're weak, and they have decreased metabolism. Recording. Orexigenic substances, or we're going to talk about an orexigenic center. Orexigenic means something that stimulates feeding. If I have an orexigenic substance, and we're going to give you some examples, they will stimulate you to eat. If something's anorexigenic, you inhibit feeding. So you've always heard of people that are anorexic, they don't want to eat. But we're going to talk about anorexigenic substances which inhibit feeding, and we're going to talk about orexigenic and anorexigenic centers in the brain, which are involved in feeding behavior. Now, the center for feeding is found in the hypothalamus. So the hypothalamus, you know, is a center for a lot of different things. One of the things, it's involved in temperature regulation. It's involved in fight or flight. Here's another one. It's involved in feeding behavior and the feeling of satiety. Now you'll notice there's a lot of different regions within the hypothalamus, which I have listed. One they call feeding centers, some they call satiety centers, etc. I will not ask you this, it's just too much. But so you understand where they figured these things out was by looking at pretty much mostly animal models where they destroyed certain centers and they figured out what happened to the feeding behavior of these animals. Now, most of you realize there's so many things involved in feeding behavior, not just the hypothalamus itself. There's higher brain centers that can influence feeding behavior. And if you look at this this picture here, there's a lot of different things that ultimately can converge on the hypothalamus, which will influence feeding behavior, your choice of food, and also one of the things that I didn't talk about that much is not only the hypothalamus affecting whether or not you want to eat or how much you want to eat, is it affects your metabolism. It can affect your activity level and secretion of hormones that are involved in metabolism. And so there are a lot of different factors that play a role in feeding behavior, and it's very, very complicated because I know there's emotional factors and a lot of different things that affect feeding behavior. But we're going to kind of look at what we see predominantly in animals, and I think humans are just too complex to kind of get everything about them. Now, here's a picture that I drew for you, and you're good enough to be able to fill in stuff for yourself if you're a visual person. If you're not a visual person, you don't need to fill in anything here. But I want you to look at, first, these two centers here, because I want to describe them, and then on the next page in your notes, there's going to be a list of different factors that will influence these centers in the hypothalamus. Now, if you look at this, the orexigenic center, if you remember the definition of orexigenic, and the orexigenic center is the center that would influence or cause you to eat more. And so if this is stimulated, this is going to converge on other neurons, which ultimately will stimulate you to increase your food intake. But it also triggers you to metabolize less. Because the idea is, I want to take in the food so I have some energy to do stuff, but I don't want to overly metabolize things because I'm like, well, then I'll have to take in some more food. So the idea is you eat more, you metabolize less. So it influences what's going on in the muscles, adipose tissue, liver, but overall they're trying to maintain a certain sort of balance. But I want you to study more about its influence on food intake over its effects on your metabolism. Now the anorexigenic center, if this is active, this is going to converge on neurons which cause you to eat less and then metabolize more. So this one's easier to remember because most people know what anorexics are. Like, well, anorexic, they don't eat and they lose weight. So if I eat less, metabolize more, I'm going to lose weight. So that one's easier. So then you're just like, well, orexigenic is the opposite. Now what becomes a little bit more complicated is to know what neurotransmitters or factors that these centers produce, which then are what influence these other neurons that regulates food intake. So let's look at the orexigenic neurons. It produces two factors, neuropeptide Y, and this is the abbreviation for neuropeptide Y, and something called agouti-related protein or agouti-related peptide. Now, these two factors, or I consider neurotransmitters, are factors that would do a couple different things. Besides, I had already mentioned about what this center does. They will cause you to eat more, and just to kind of make sure you're eating more, metabolizing less, these will inhibit the anorexigenic center. So the idea is, if this center is active, you want to go and inhibit the alternate or the opposite center. And the same will hold true when the anorexigenic center is active. It's going to cause you to eat less and simultaneously inhibit the orexigenic center. Now, if you look at the anorexigenic center, it produces a couple neurogenic factors that both decrease food intake and increase energy expenditure. One is called alpha melanocyte stimulating hormone. So you're like, wow, melanocyte stimulating hormone. Shouldn't that stimulate melanocytes to make melanin so you're darker? Well, this thing, melanocyte stimulating hormone, is a neurotransmitter. And it's produced up in the brain by neurons that actually, they make it from a precursor called pro-opiomelanocortin, or POMC. But if you just remember the alpha MSH, you're good. Now here's one that's, to me, easier to remember. The acronym is CART. It stands for cocaine and amphetamine-related transcript. So this is a factor that they found was very much related to cocaine and amphetamine that people would ingest. So if you take cocaine or you take amphetamines, those are notoriously known for causing weight loss and inhibiting food intake. People would take amphetamines to stay awake to study, but they also would lose weight and they don't want to eat. Cocaine does the same thing. You look at people who are cocaine addicts, they're extremely skinny and small. They don't want to eat. So that one's kind of easier to remember. A cocaine and amphetamine-related transcript inhibits feeding behavior. So that is released by the anorexigenic center. So these are the centers within the hypothalamus. These are the factors that mediate their effects on food intake and energy metabolism. What we need to do is look at factors externally outside of the brain that will influence or converge upon these different centers and either inhibit or stimulate food intake. So we're going to have receptors on these centers for various factors that are produced either, like, say, in the intestine, the stomach, adipose tissue, pancreas, that could influence feeding behavior. Now, if you notice in your notes, you have some various GI hormones that are in bold, and it's under the heading, factors that regulate feeding behavior short term. So the idea is short term is these will kick in during a meal or shortly after a meal, and its idea is to prevent overeating at a meal. And it's short term, or it's quicker to act, because this is before any nutritional factors have been absorbed in the blood. So you've eaten, you've had your carbs, and you broke them down to monosaccharides. They take some time for that to happen. So these things are working before the complete metabolism of what you've eaten. So one of the GI hormones, the ones that I want you to look at, is you got the ones that I want to talk about. You can eliminate the other ones. Is cholecystokinin, because we've talked about that many a time, and ghrelin. So those are the two that I want you to concentrate on. The other ones you can eliminate. So cholecystokinin. Who remembers where it's made? You better remember where it's made. So cholecystokinin, we said it was produced in the small intestine. Don't worry about the cell, with specific cell type. But it's produced in the intestine, and one of the major things that stimulate cholecystokinin to be released is fat. So it's a response to fat in the intestine. And so cholecystokinin, if you draw a little picture, you can do it here, or you can draw it like down in here, because this is where the small intestine is. Cholecystokinin is released in response to fat in the intestine. We know what it does to the gallbladder. We know what it does to other things, but now let's talk about how it regulates feeding behavior. Well, its receptor is up here in the anorexigenic center. It works through the POMC, the pro-opiomelanocortin, where it ultimately, that's the precursor, you make this alpha MSH. So the cholecystokinin binds to the anorexigenic center and causes you to stop eating or eat less. So you can kind of think about this, is we had mentioned this before in regards to stomach emptying, is if you've got fat in the small intestine, it slows stomach emptying, makes you feel fuller longer, but it also makes you, it's better at satiety. It makes you feel a little bit more satisfied if you have a little bit more fat in your meal. And so what it does is it also stimulates you to say, okay, enough's enough, we don't need to eat as much, so you eat less. And it works through the anorexigenic center. The other one that I want to talk about is called ghrelin, Ghrelin. That is produced in cells within the stomach, and mainly the exyntic cells, OXYNTIC, the exyntic cells in the stomach, in response to fasting. So when you haven't eaten, you've been fasting, Ghrelin is produced by the stomach, and this is how I always can remember what ghrelin does. Ghrelin makes your belly go grrr. So you ever think that the rumbling that takes place in your stomach? Well, if you haven't eaten, ghrelin's released. It's a hormone that's released, and what it does is it increases feeding. Makes it, hey, you need to eat. I want to eat. So that's what ghrelin does. Now, ghrelin is going to have a receptor up here in the orexigenic neurons. So it's going to stimulate you to eat. Now, primarily the research on ghrelin has come from animals. The effects in humans are relatively unclear, so they're still working on it, but it is considered to stimulate feeding. Now, the one thing I want to talk about is in regards to intermediate and long-term effects on feeding behavior is a hormone produced by the adipose tissue. So adipose tissue is an endocrine organ too because it does produce a hormone. And the hormone is called leptin. Now, leptin has gotten a lot of press in the past few years, and I'll tell you about what they say or what it does, and that what people think, oh, we can use this for weight loss, but I'll tell you why it hasn't really worked very well. Now, leptin is a peptide hormone produced by adipose tissue when the adipose tissue levels or the fat levels increase. Well, we have receptors in the anorexigenic center for it. They're going to stimulate. It stimulates this center, says, okay, you've got enough. My fat stores are there. You need to stop eating. Okay? But it also targets, leptin also targets the orexigenic center, but what it does there is it inhibits the orexigenic center, which again makes sense. Got enough fat, I don't need to eat anymore. So what it primarily does is it inhibits feeding behavior. It also, leptin targets targets up to the vasomotor center, which stimulates the sympathetics, causes you to increase metabolic rate, increase expenditure of energy, because that whole idea, again, is like, okay, I got a little excess fat, let's break it down. I don't need it. What it also does, which is kind of interesting, is it decreases insulin. So you can draw a little line. Leptin over here goes up to the pancreas and inhibits the secretion of insulin by the pancreas. Because insulin is all about fat storage. Leptin says you got enough fat storage, stop producing insulin. And so it kind of has a multiple effects there. So leptin, the idea, all this research they did on animals, they're like, ooh, leptin causes you to increase your metabolism, causes you to stop feeding behavior. Why can't we use this as a means for weight loss? Because they're like, well, there was a model where an animal was deficient in leptin, and they were overweight and fat. Just like, and maybe some individuals, these people who are hugely obese, that they had a deficient in leptin. That's extremely, extremely rare. And then all the people that did the research about leptin and doing animal models and stuff to say, let's see if we can make a magic pill that, stimulate leptin released by adipose tissue, or just give someone leptin, maybe we can promote weight loss. Nothing really has come out from that. A lot of research went into it, and it really hasn't been promising in any way, shape, or form. And the idea is you think, well, heck, if this thing worked as well as it did, as soon as my fat stores got a certain level, then I should be not eating as much, and I should be metabolizing more. And we know that doesn't work, because we got plenty of people who've got a lot of fat out there and still are eating, and they're not metabolizing it. So the leptin is just one thing involved in this total idea of things that affect metabolism in feeding behavior. Now, if you've got someone with an excess amount of adipose tissue, that's not always a good thing. But we're going to talk about that in a second, obesity. But I want to look at the effects of temperature regulation on food intake and your metabolism, because this kind of ties in a couple of the different lectures that we've done. If you're exposed to the cold, Cold exposure, what it does, it stimulates the secretion of thyrotropin-releasing hormone by the hypothalamus, which then targets the anterior pituitary and stimulates the release of TSH. We know what TSH does. It targets the thyroid gland and stimulates growth of the thyroid gland and the production of thyroid hormones. And we know that thyroid hormones, one of the effects is to increase metabolism. And when you do that, you start producing more heat. And that's the whole idea. If I metabolize some fat, byproduct that is heat, and that's trying to be protective with exposure to cold. But it also does is increases feeding. So if you look at people that are from like the Arctic or the Eskimos, things like that, they need to eat a lot to maintain, to kind of keep a little bit more fat storage on there because it's an insulator. But they also produce all these thyroid hormones that causes the metabolism of the fat for generation of heat. But again, you got to have the fat to metabolize. And so they eat more and they store a little bit more fat, but they also increase their metabolism. If you expose an animal to a lot of heat, it decreases feeding behavior. Now, a lot of people can kind of think about it's like if it's too hot outside, most people it's like, oh, I don't even want to eat. It's just too hot to even eat. So most of us can kind of appreciate that a little bit, that you don't want to eat as much when it's real hot. You tend to want to eat more when it's cold out. Now, there's a couple other theories behind what regulates feeding behavior, and they're pretty much theories. And you can kind of get from just looking at the name is various substances. If they're decreased in your blood, they will trigger hunger. So the first theory is glucostatic. If your blood sugar levels are decreased, it triggers hunger. Second one, the aminostatic one. If you've got a decrease in amino acids, not enough protein intake, triggers hunger. And the last one, if you have a decrease in fatty acids in the blood, that triggers hunger. So that's another theory behind what they consider to be regulating food intake. It's by what you don't have. It's like, okay, I need it, so I'm going to want to feed some more. Now, we're going to look at now is conditions that are associated with either too much feeding, not enough metabolism, or vice versa. So the first one we'll look at is obesity. Obesity is a condition in which a person has excess body fat for their size. The clinical tool, commonly clinical tool, for determining if a patient or a person is obese is the body mass index. There are a lot. You can go online, plug in certain things, and it'll give it to you. You plug in your weight, and even if you don't know your weight in kilograms, you can put it in pounds. It'll convert it for you. It takes your weight in kilograms and divides by your height in square meters. Okay, and again, you can plug it in, and they'll tell you what your body mass index. Now, the body mass index, the values in which you're considered to be obese, underweight, normal, overweight are in your lecture manual. And these are numbers to kind of know, even though I'm going to tell you I do not like to use the body mass index. But you have to be aware of the body mass index. It's very easy to do. It's quick. It's commonly done because of its ease of use. If you have a body mass index of over 30, you are obese. Okay? If you have a body mass index between 25 and 29.9 in this yellow zone, you're considered to be overweight. If you're in this green zone here, between 18.5 and 24.9, you're normal weight. And if you're less than 18.5, you're considered to be underweight. You don't have enough body fat. Well, I have a problem with the use of body mass index. Even though it's commonly used, easy to do, it does not take into consideration muscle mass. If someone has more muscle mass, they're going to weigh a lot more. Muscle weighs more than fat. The people who are going to be smaller, they're going to weigh more, and it's going to say, oh, they're obese because for their height, they weigh too much. But it does not take into consideration muscle mass. I wish they'd outlaw body mass index. They need to have people actually have their body fat measured directly using calipers or the underwater method of testing for muscle mass and all that. So it's limited. It's commonly used, but I don't pull out of weight into it, and no pun intended. Now, so it's better if you have your body fat percentage measured, and they considered if you're a male, if your body fat percentage is over 25, you're obese. Girls were over 35% fat were considered to be obese. Now, girls were allowed a little bit more body fat than the men because we need it as for procreation. We need more muscle mass for having children, and also it's very important if a woman has too little body fat, they will not menstruate. So some women do not menstruate because their body fat percentage is too low, and you need menstruation, or you have to have normal cycles just to produce more normal levels of estrogens and progesterones. And you could think about what happens if a girl who starves herself or works out too much and her body fat percentage is too low, they don't cycle correctly, they're not producing these hormones, and some of those hormones are involved in maintaining bone density, and so that's not healthy either. Now, there's different classifications of obesity. They have one called hyperplastic obesity and another one called hypertrophic obesity. A hyperplastic obesity, the idea is that you get weight gain, and it's because of creation of new adipocytes. And hypertrophic obesity is the adipocytes actually get bigger. And we all usually been hammered in our heads for a lot of things that, like for muscle, generally muscle, we just get hypertrophy of muscle. We don't get hyperplasia of muscle. But they found that with adipocytes, they thought mainly as a child you would get hyperplastic obesity, and then you wouldn't get that as an adult. As an adult, it'd be more hypertrophic. But they found that we can have both as an adult. You can make more adipocytes, and the adipocytes that you have can get bigger, which I thought was kind of interesting. And both, again, associated with excessive weight gain. Well, most of you could tell me what are some causes of obesity. Most people could just like list them off. Okay, we eat way too much. We eat the wrong stuff. We have sedentary lifestyles. Then you have some people that have, because of psychological issues, social issues, they have abnormal feeding behaviors. But there are some, it's a small part, that is some genetic factors that are associated with it, and maybe some abnormalities within the hypothalamus and stuff like that. But they're not quite as, what's the word I want, not as common. And even if we talk about genetic factors, you have a genetic predisposition being obese, but it's still the environment. If you don't eat, then you're not going to get fat. If you're not active, then you're going to get fat, and vice versa. So generally, even though you may have a genetic predisposition, both parents were overweight and fat and all that, it's your lifestyle's the main thing. So you can control your environment. Now, treatment, again, what are some treatments? Chiropractic would aim for changing lifestyles, making sure our energy expenditure was greater than our energy intake. You need to exercise, put a little more bulk in your diet in regards to fiber. The question mark is, and chiropractors would probably not advocate drugs or surgery, and even some people will say, well, surgery may be warranted for those people who are excessively overweight, the bedridden people. They need to have like their stomach stapled or the gastric band or whatever. But again, those treatments are going to be limited. There's plenty of people who've had gastric bypass or their stomach stapled that actually gain the weight back. So lots of times it's a good part of being overweight for a lot of people. It's psychological issues, and people need to address the psychological issues before they jump the gun and try to do surgery, because if they don't address the psychological issues, they're just going to gain the weight back. Even with people who didn't go through the route of surgery, who lost weight, but then all of a sudden they gain it back because there's something that causes them to overeat or not want to work out. So that has to be addressed too. Now here, inanition, what he had mentioned earlier, is the opposite of obesity. So these people lose weight. Remember, they got muscle weakness. They're going to have decreased metabolism. Now, it could be a couple things that could result in inanition. Now, this poor child, it wasn't because he didn't want to eat. It's because it wasn't available to him. So sometimes it's just the food is not made available to you. And some of it can be a pathologic or pathophysiologic condition in which you either don't eat or there's something else that's involved. And we're going to look at a condition called Cachexia. So here, this child has this condition of inanition because the food intake was decreased. It is not because it was voluntarily decreased. It's just because he didn't have it available to him. Now, this woman decreased her food intake voluntarily. She has what we call anorexia. So anorexia can lead to that condition of inanition. Now, this woman has what we call anorexia nervosa. Now, this is a psychological condition where the men or women view themselves as being fat or overweight, and they'll starve themselves. Okay? They don't have an appetite. Now, you can be anorexic and not have what this woman has, where you think you're fat, so you're not going to eat. Being anorexic can be a result from other conditions that cause you not want to eat. People who have cancer or certain other conditions, it causes them not wanting to eat, and they can have a condition of anorexia. So don't always think anorexia is because of those, you always get the women who starve themselves. Men can starve themselves too, but anorexia nervosa is a specific condition. It's a psychological condition where they decrease food intake because they view themselves as being fat. You can be anorexic in regards to some other illness, and you just don't want to eat. Now here, condition called cachexia. If you have cachexia, you're losing body weight, and even if they try to do IV infusion of nutrients and things like that, they still will lose body weight. It cannot be reversed nutritionally. So someone continues to lose weight despite the fact that they're given food. That's called cachexia. Now, this is often associated with things like cancer patients, people with AIDS, chronic obstructive pulmonary disease, congestive heart failure, a lot of different conditions, pathologic conditions, can lead to cachexia. And if you have this in a patient with any of these conditions, it is considered to be a positive risk factor for death. The chances of those people dying is greatly increased if they have cachexia, because no matter what they do, they cannot reverse that loss of body weight nutritionally. So body weight loss, we see someone to this point, this person has absolutely no muscle. Muscle is not just the muscle for movement in regards to like legs and arms. What about the muscle associated with the heart and other important vital organs? They're going to start to fail. So this is a really, really bad thing. Okay, so again, cachexia and anorexia kind of fall under under the category of inanition, and they're kind of a little bit separate. Okay, so anorexia, decrease in food intake, either voluntarily or involuntarily. Cachexia, you're losing body weight but just can't be reversed nutritionally. Okay, sometimes again with some people with these conditions, they are also anorexic too, but not necessarily. Now this is going to be the end of the first part of the webinar over dietary balances. The second webinar is going to be very, very short, and it's going to just cover the vitamins and minerals.